Okay, so with this question here, we've got a mass of 80 kilograms lying on an inclined plane, okay, where the angle here is alpha, right? Now let me tell you something about that, because if you notice here, it says sine alpha is 3 over 5, okay? Now that's useful because, as you can see here, when you resolve, right, you've got sine alpha, but you've also got cos alpha. If they tell you sine alpha, easy to get cos alpha, because what you can do is you can construct a triangle, right, by the side here, right angle triangle. And if I label that alpha there, yeah, now if you think about, you know, SOHCAHTOA with your right angle triangle, of course this would be the opposite, wouldn't it, opposite the angle. This would be your adjacent next to the angles, and you've got your hypotenuse there, okay, opposite the right angle. Now in case of sine, right, sine alpha, if you think of a sine is O over H, isn't it? Okay, O over H, which in this case they're saying is 3 over 5. Okay, well that means then the O is equal to 3, okay, and the H is equal to 5, right? Now it's easily enough then to work out what A is, okay, because you could use Pythagoras, couldn't you? You've got 5 for the hypotenuse, 3 here, you could work out what A is. So this squared plus this squared is this squared, okay, or you could take 5 squared, the hypotenuse squared, take away the smaller side squared, okay, and that turns out to be 16, and of course then you square root to 16 and you get 4, you get this side here. Now what's good about that is, of course this is what we call the 3, 4, 5 triangle, it works out nicely. What's good is you can now work out what cos alpha is. Cos alpha, of course, remember, is A over H, A over H, so it'll be 4 over 5. Okay, so that's useful for when we answer part A, for instance, because in part A it asks for the normal reaction of the plane on the body. So you can see here the normal reaction, of course, is perpendicular to the plane, and that will equal, okay, the force opposing it. So that's the weight resolved in that direction, so 80g cos alpha. Okay, there's no movement perpendicular to the plane, so we can literally say R will equal to 80g cos alpha. Okay, so of course then we know G is 9.8. Cos alpha, as we worked out, is 4 over 5. Okay, so we'll work that out, and we get out to be 627.2 newtons. Okay, so then it says, Poppy, the body is on the point of slipping down the plane. Find the value of mu. Now you'd expect it to slip down the plane, wouldn't you? Because it's just there, and you'd expect it just to slide. So if it's going to go this way, that means friction is acting that way, up that way. Yeah, I'm not going to draw it in because part C gives us a different situation, and I'll wait till part C before I start adding more on here. Okay, so save me having to draw the diagram again. But if it was on the point of slipping down, you'd appreciate that friction will be acting up. So first and foremost, you could say, look, if it is on the point of slipping, okay, I think it's very important to remember that if it's on the point of slipping, friction is at its max, yeah? Friction is actually equal to mu r, okay? That's kind of important for the question here, because they're asking us to find the value of mu, yeah? So that will be the case there. But if we then resolve along the plane, okay, well it's not moving, even though it's on the point of slipping, it still hasn't moved. So basically this force here, which is the weight resolved, will equal the friction that's opposing it. So we say, look, 80g sine alpha will equal to the friction. Okay, and of course what's good is 80g is 80 times 9.8. We know sine alpha to be 3 over 5. Friction we know to be mu r, so that'll be mu times the reaction, which is 627.2. We worked out earlier. So a little bit of calculated work here, and then we can get our value for mu. Okay, so on the left hand side here, that's 470.4. Of course, then to get mu, we divide that answer we just got by 627.2, and it works out nicely that mu is just 3/4. Okay, exactly, 0.75 or you can write it as a fraction 3/4. Okay, so then you part C then, it says calculate the magnitude of the frictional force, acting along a line of greatest slope that will make the body, move the body up the plane with an acceleration of 0.7. So now I'm going to use this diagram to help me. So basically there's a force now being applied to this object along the line of greatest slope, it says, along the line of greatest slope. So in other words, parallel to the slope, that's what that means, along the line of greatest slope, parallel to it, but it's going to be pushing it up. Now if it's pushing it up and it wants to move up, and it will move up, so we'll call this, excuse me, we'll call this force say T, okay? Well, of course then friction will be acting down, won't it? It'll be going the other way, friction will. Okay? Friction will be going the other way because ultimately we've got the object going up the hill. Okay, so friction then is going to oppose the motion, so it's going to go down. Okay, so we need to work out what this force is. Okay, we need to work out the size of it. We know it's accelerating, as it says, up the hill, and of course the acceleration is 0.7. It says that. So if we apply Newton's second law, okay, in direction of motion, so we'll have this force that's been applied, we called it T. Take away then, while the weight component, which is 80g, so 80 times 9.8 times sine alpha, just 3/5. Take away also then the friction. Okay, so these two are opposing it, so take away the friction, and that will equal to then the mass, which is 80, the mass of the object is 80, times then the acceleration, which is 0.7. Okay, so it's a case then of, well, we can work this out here, 80 times 9.8 times 3/5, so we get that to be 470.4, as we had earlier on. Friction, don't forget, is mu r, right? So we know in this case here that mu was 3/4, wasn't it? Okay, perhaps I'll just write that down first. 80 times 0.7, 56. So T minus 470.4. Take away mu, which is 3/4, times then reaction, which, if you remember, the reaction was 627.2, 56, and then it's a case of just taking everything over to the side there, okay, to work out what our T force is. And T should come out to be there 996.8 newtons.